Hello everyone, welcome to today's video. Finally, the most awaited day uh, has come. So today, Prabhu Sri Ram will be, coming back to Ayodhya, and today is the inauguration of the Ayodhya temple, Ayodhya Mandir, right? So we're all waiting for this. We are all craving for this. Finally, this day has come. So let us all take a moment of our busy schedule and pray to Prabhu Srinam. Okay, so the reason is, irrespective of religion, irrespective of your what do you say, beliefs and etc. Prabhu Srinam is an embodiment of many things. Okay, he's an embodiment of righteousness. He's an embodiment of dedication. He's an embodiment of true leadership. He is an embodiment of a true son. So he is an embodiment of everything whatever you want, like to see a perfect character in any man. So all those characters will be there in Lord's Prabhu Sri Ram. Okay, so he is an embodiment of those things, and the difficulties he faced in his life, the hard times that he faced in his life. So we all face that very often, but we happily give up, we easily give up. But these are all the things that we need to learn from him, that no matter whatever the hurdle or the difficulty that we are going to face, we must make sure we do not give up and we do not follow the adharma pathway. Okay, so we must only follow a dharma. Okay, we must only follow the dharma. So then only we'll be not causing any harm to others, and also there'll be no greed in our journey, right? So this is always important to remember, and Prabhu Sriram is an embodiment of all these things. So no matter what the hurdles or difficulties he had faced in his life, he never chose an non-dharmic path, right? So it's important that we pray to him, because in this today's generation where the culture is being deprived of all the things, right? Wherever you see a lot of western things are happening, a lot of things have changed, like we do not see the true Indian feeling wherever you go. So everything has changed. So the true Sanatana vibe is really missing these days. So Prabhu Sri Ram must actually, we must pray him to get those things back to our India, and have a prosperous time ahead for us. Because when Prabhu Sri Ram is ruling Ayodhya, so there is not even a small ant or insect was having any trouble. So that is the power of his ruling. The same thing we must also expect in the coming days, because he's stepping now, he's coming back to our hearts of our Indians. So he needs to he will do something for us. That is the power of Lord Prabhu Sri Ram. So we must all pray for him, right? So let us all take a moment and do not forget to witness the powerful inauguration, right? So let us proceed further with the problem. So today's problem is paths from root with a specified sum. So this is a medium level problem, and it's the problem of the day on Geeks for Geeks today. So what is the problem saying? Given a binary tree and a sum, yes, print all the paths starting from root that sums up to the given sum, and path may not be ending on a leaf node. Okay, sorry. So you people might have easily done this, because we are all solving a lot of harder level problems these days, and this should be an easy cakewalk for you people. Some people would have already framed the logic, but would have stuck in the this thing, coding part and all. So need not worry, I'll even explain that. But I hope, hopefully many of you would have solved this. So let us go through the question through some examples. So this is the example that has been given. So this is the input, the sum or the target they are looking for is 38, and if you carefully observe the outputs, 10 28, so 10 28, so this is a path, right? So in this path you are getting a sum of 38. 10 plus 28 equal to 38. And what's another path that they are telling? 10 13 15. So 10 13 15. So in this path as well, 10 plus 13 23 plus 15 38. In this as well, you'll be getting the sum as 38, and no other pathway you'll be getting a sum as to be 38. So it's basically you're starting from this point. This point is for sure, and you're ending up at some point. Okay, ending up at some point such that if you end, that means you have got a some required target. If you're not stopping there and going back, exploring other ways is also possible. So that is also one of the case scenarios that we'll be seeing now. So the hopefully you have understood the problem. So it's like, if you're starting from the root, okay, if you're starting from the root, go till those points, and if you're finding any sum, any path that's giving you an exact target, so take that into your consideration. Okay, take that into the consideration. That's the same, that's the only thing they are asking for. So what else is there? It's pretty pretty evident, right? So first you'll be taking the root value. Okay, first you'll be taking the root value, you'll be adding that, right? You'll be adding that, or you'll be taking that into your consideration. So you'll be taking a vector, you'll be taking a vector int path. Okay, vector int path. So you'll be taking this root into your consideration, and after considering this root value, after taking this into picture, if your sum, okay, if your sum gets equal to the target sum, okay, if your current sum or whatever the variable you're going to put, if your target sum is, if your present sum is equal to target sum, then you can just push that pathway into that particular path into your pathway. Okay, I've taken a 2D vector paths in which all the vectors are the required paths, required path. Okay, so paths dot push back of path. Okay, so this is the 2D vector that we are supposed to return. So paths, so it's a plural form of path. So wherever path we are going to get, that I'm pushing into the paths 2D vector. And finally, so after this, after doing this, now you can even explore the other paths. Okay, so how do you explore the other parts? Root left. So if you are sticking on this, like if you are on this, you have root left and root right, right? So you can just call those recursions or whatever you're doing, so onto your left. So find, if you're writing this as a function name find, so root left, okay, root left, and what are the other parameters that you're going to have, and also the other thing is find root right and other parameters that you're going to have. Okay, so these parts, and finally once you're done exploring all these things, remove that. Okay, path dot pop back of particular root value. Okay, root value or root data, whatever that is given, like root pop back or root data. Why are we doing a path dot like pop back? So pop back in the sense delete, right? Delete. So once you have explored all these things, so let us assume you're or I'll just remove this. Let us assume you are on this 14. Okay, so 14, you have taken this 14 into consideration, and then you have come to 21, and after 21 you need to pop back 21, isn't it? Because you're going to get into 22, right? You're going to come into the world of 22. Is there any inclusion of world of 21 in 22? No, there is no involvement of 22. So you must pop back, right? And also once you're done with 22, you'll also pop back 22, and because there are no left and right child for it, so once it enters, you'll just check if your sum is equal to target sum, and after that you'll just pop back. Okay, so after that, so similarly 14 also, once you're done with the world of 14, once you have explored the left subtrees and right subtrees of 14, it's your duty to eliminate it, because now you're going to enter the world of 15. 14 world is not going to enter 15 world. That is a complete subtree, different subtree 14s, and it's a complete different subtree 15s. So you cannot include this here. So it's your primary duty to delete this and then enter into this world. And once you're even done, you will even delete this, right? So this goes on, right? So you're deleting and adding. Maximum it goes up to the height of the tree. Maximum it goes up to the height of the tree, the space, right? The space complexity, whatever you're talking about, goes up to the height of the tree. That's it. So because once you have explored some particular pathway, you're deleting the elements. No, you're no more storing it. So it's just the height of the path is what you'll be storing, maximum, right? So it's very common sense thing. And time complexity is O of n square. The reason being, for each and every sub node we are exploring all the paths, right? Each and every node we are exploring all the paths. So in the worst case, it is O of n into n, that is O of n square. So each and every node you're visiting, and for each and every node that you're visiting, you're visiting all of its subtree left and right. So O of n into n, that is O of n square. This is the worst case. I hope you people have understood. So we have taken a path variable, we are exploring each and every node, pushing them into our path, and checking if the particular sum is actually equal to the target sum. Okay, if it is actually equal to, then push that particular vector into your paths 2D vector, and now call the recursion onto your left side and your right subtree, and then finally pop it back. That is very, very important. So the same thing I have even coded here. uh, sorry for the disturbance. So vector int path, this is the 1D vector. Okay, this is a path, 1D vector of path, and you're doing find paths. So if your particular route is not defined, just written. And now current sum, you're taking that into consideration. Okay, consideration, and pushing back, this is also consideration. Okay, consideration into your current sum and your path pushing it. And if you're, in case your current sum is actually equal to your target, then push it into 2D vectors, push it into 2D vectors, 2D vector. And now call the recursion on left, and now call the recursion on right, and then delete. Okay, so primary duty, this is very important. And I've declared a global variable, global vector, 2D vector, vector in paths. So finally, after this whole function is done, we'll be returning that paths, right? So it's very easy question, to be honest. And the codes in Java, Python, C++ are there in the description. You can just go through them, and even I'm submitting for your reference. Yeah, it's done. So yes, so we have solved this problem. So that's it guys for today's video. And also I would like to mention about my WhatsApp community that I've created. If you're interested to join it, do consider joining it, because I'm posting off-campus opportunities over there. Very soon I'll be extending it to some DSA tips and tricks, etc., whatever related to software, I'll be putting it there. So very soon I'll be doing it. As of now, I'm just confined to off-campus opportunities, either it may be placements or internships, right? So hopefully you all do it, right? So that's it guys, thank you for watching this video. Jai Sri Ram.